In the second example, we need the formulae for the squares of binomials. If you expand a plus b in parentheses squared, if you multiply these a plus b times a plus b, you get a polynomial a squared plus 2 times ab plus b squared. And this formula can be for factorizing particular suitable polynomials of this form. The same way, if you expand a minus b squared, you get a squared minus 2ab plus b squared. And if a polynomial is of this form, you can factorize it this way. And also a plus b times a minus b. If you multiply a times a is a squared, a times b minus b, you get minus ab, then plus ba, which two terms cancel each other, and then finally you just get minus b squared. This type of polynomials we can always write as a product like here. Our first example was x squared plus 4x plus 4. Which of these forms this polynomial might be? Okay, it has 3 terms, it's either the first or the second, and it has no minus sign, so it might be the first. So instead of a, we have x, true, and what might be b here? 4 is something squared, 4 is 2 squared. So can we write 4x as 2 times the x times 2? Actually, it is 4x. So if we write this like this, x squared plus 2 times x times 2 plus 2 squared. And compare this, this is true, same polynomial as above. And if we compare this to this first, it is exactly the same, of the same form. Instead of a we have x, and instead of b we have 2. So this must be x plus 2 squared. And you can always check. Multiply x plus 2 times x plus 2. Another example, 4x squared minus 12x plus 9. This has 3 terms and it has minus sign for the middle term. This formula might be suitable in this case. Let's check. 4x squared, this whole thing should be something squared. Okay, but if we write 2x in parentheses squared, that is the same as 4x squared. Minus, then we should have 2 times a, and instead of a we have 2x. And if we have 12x, so, and here we have minus 2 times 2, that's 4, we should still have times 3. But that's nice, because the term 9 can be written as 3 squared. Now this polynomial is exactly the same form as this second, and instead of a we have 2x, and instead of b we have 3. So this must be 2x minus 3 squared. Okay, and part C, 9x squared minus 1. This has 2 terms. Can we write these 2 terms as squares of something, second powers of something? Okay, 9x squared is actually 3x in parentheses squared. And then 1 is just 1 squared. Now this is exactly of the same form as here. Instead of a we have 3x, instead of b we have 1. To apply, we can apply this rule, so this when factorized is 3x plus 1 times 3x minus 1.